Rubberized asphalt concrete, or RAC, is a blend of asphalt cement, ground-up tire rubber, and other additives. RAC outperforms traditional asphalt in both engineering and environmental benefits. Engineering benefits include improved durability as a surface layer, protection against fatigue cracking, less reflection cracking, resistance to aging, reduced thickness design, lower overall life cycle costs. Environmental benefits include tires are upcycled rather than stockpiled or put in landfills. RAC itself is recyclable. RAC is initially a quieter surface to drive on, contributing to California's zero-waste goal. Grants are available from CalRecycle. To learn more about the environmental and engineering benefits of RAC, visit www.calrecycle.ca.gov/tires/RAC. Although RAC is superior in many ways to conventional asphalt, there are some situations where it should not be used. Because the mix must be transported and compacted at an elevated temperature, it shouldn't be used on projects with a long haul time or distance. Rule of thumb is about 1 hour from the hot plant to the job site. It also shouldn't be used if site temperatures are less than 55 degrees Fahrenheit or if rain is imminent. Use of warm mix additives has improved the haul range and a lower compaction temperature. The definition of asphalt rubber has been identified by several ASTM standards: ASTM D8, ASTM D6114. Rubber modification of asphalt concrete mixes can be accomplished using two distinct wet processes: the high viscosity agitation method and the low viscosity no agitation method, commonly referred to as a terminal blend. The wet process requires thoroughly mixing crumb rubber modifier, known as CRM, into asphalt cement. The resulting blend must be held at an elevated temperature for a designated period of time to permit an interaction between the CRM and the asphalt cement. This blending is performed at the hot plant. The high viscosity agitated wet process uses the largest amount of rubber tires and is most effective in gap-graded and open mix designs. It is not suitable for dense graded mixes. It is also most effective when used on relatively thin surface lifts. Gap-graded mixes remove some of the fine sands that are replaced with the rubber crumb. They are used as a structural layer equivalent to conventional dense-graded hot mix asphalt. Open-graded mixes are used in surface friction courses. Terminal blend rubberized asphalt is made at the refinery, where a finely graded rubber crumb is fully digested into the liquid asphalt and shipped to the hot plant. Terminal blends are used in dense graded mixes. These mixes are recommended on parking lots and where parallel parking is prevalent. Production methods for the high viscosity asphalt rubber binders are essentially the same for both hot mix and spray applications. For spray applications, the crumb rubber and liquid asphalt are blended in the distributor truck. Operations are split into two components: aggregate production and binder production. Aggregate production follows the normal manufacturing process for conventional hot mix asphalt. This is comprised of the quarried aggregate being processed into the specified gradations as identified by the mix design. Additional equipment is required on-site to produce the RAC asphalt rubber binder product. The binder production process begins with the delivery of asphalt binder. The standard grades required by Caltrans for RAC are PG64-16 and PG58-22, although other grades may be used depending on the prevailing climate. Other storage tanks contain the extender oils and anti-strip agents. Please note that polymers are not currently used in high-viscosity RAC mixes. The heat tank is required to raise the asphalt cement to a range of 400 to 425 degrees Fahrenheit. The blending unit is where crumb rubber is blended with the elevated hot performance graded or PG binder. Once thoroughly blended, these materials are then pumped into the reaction vessel. The blended mix typically contains 18 to 22% crumb rubber with particle sizes ranging from number 8 to number 10 top size and can include extender oils and other additives such as anti-strip agents. The reaction vessel is a tank that contains motor-driven agitators that keep the rubber particles dispersed in the hot asphalt. This allows the RAC to interact for a designated period, typically 45 to 60 minutes with continuous mechanical agitation. The CRM particles swell and exchange oils with the asphalt cement. Documentation at this phase of production can include certificates of compliance and source information for the PG binder, extender oils, admixtures, crumb rubber gradations and composition, and material sources. This should also include the RAC binder design and the RAC binder production logs. If your agency is participating in the CalRecycle grant, Form 739 TRP, certification that tires used are only from California must be supplied by the crumb rubber provider. Frequency of sampling and testing may vary depending on the nature of the materials, project size, and available resources. Aside from minimum specified requirements, additional sampling is recommended wherever changes in any material or its behavior are observed. Sampling during production and construction is relatively easy and inexpensive. It is rarely necessary to test every sample obtained. Use standard practices for material testing as per conventional hot mix asphalt or HMA. At least one viscosity test is required to establish compliance for each asphalt rubber batch and holdover load. Measurement is determined by a rotational viscometer and presented in centipoise. The RAC binder and aggregate are now combined using conventional HMA processes. The RAC mix produced is now stored in silos, ready for delivery to the job site in trucks. Temperature of the material at this point should range from 320 to 335 degrees Fahrenheit. Any crack sealing, base repair, and leveling courses should be completed prior to RAC placement with conventional materials and mixes. Please note that crack seal should be down in the crack and not over-banded on the surface. Hot RAC can rejuvenate the crack seal and possibly cause a slip in the mat. Sweeping of pavement and proper RAC coating are critical. Temperature management is essential to successful RAC mix placement and compaction. It should be noted that high-viscosity RAC mixes are very sticky, have a rubber odor, and are not conducive to large amounts of handwork. Materials must leave the plant at a minimum of 315 degrees Fahrenheit. Tarping of truckloads is generally specified. RAC may not be the best choice on projects with the following conditions: long haul time or distance, site temperatures less than 55 degrees Fahrenheit, or if rain is imminent. Good practices for conventional HMA placement shall be adopted. Special attention should be paid to temperature management. Coordination of the binder production, mix delivery, placement of material, and compaction are essential to provide for the service design life of the pavement. In short, density is controlled by the material temperature and compacted effort. 95% of the compaction density can be achieved during the breakdown rolling process. A steel drum breakdown roller must be used in vibratory mode with a mat temperature of above 280 degrees Fahrenheit. If all compaction does not take place above 250 degrees Fahrenheit, RAC does not compact further when cool and could lead to failure. It should be stressed that rubber tire rollers shall not be used whatsoever for RAC compactive efforts. The paver should be equipped with a fully operational screed leveling device. RAC mixes and laydown temperatures should be monitored using infrared and stab thermometers. These devices should be calibrated on a regular basis. RAC should not be placed with an ambient or road surface temperature of less than 55 degrees Fahrenheit. Traffic should not be allowed on the finished mat until the surface temperature of the mat is below 150 degrees Fahrenheit. If this is not possible, a sand or dust blotting application should be applied at an application rate of 2 pounds per square yard. This acts as a bond breaker and not a cooling agent, and shall be applied only after all compaction effort is completed. Approach to structural design depends on the intended purpose for the RAC pavement, which may include preservation, maintenance, or rehabilitation. The use of the half-thickness equivalents for using RAC overlays can be accommodated by following prescribed details for rehabilitation and design strategies in the following documents: Caltrans Flexible Rehabilitation Manual, Caltrans Highway Design Manual. Caltrans highlights the need to verify that both structural adequacy and reflective cracking requirements are analyzed, reviewed, and fulfilled for all flexible pavements and roadway rehabilitation structural designs. It should be noted that Caltrans allows the use of a thickness equivalency factor of not more than 1:2 to RAC gap-graded mixes when compared to conventional asphalt for reflective crack retardation only. In a study of 377 Caltrans and local agency projects statewide, the average of all projects found that in-place RAC costs were about 10% higher than conventional mix. The tonnage and geographic location have an influence on price. However, this slight increase in price is offset from a life cycle perspective by the increased longevity, reduced thickness, and less maintenance RAC provides. Visit www.calrecycle.ca.gov/tires/RAC to find out if rubberized asphalt concrete is a good fit for your project.